Good morning, students. Welcome to 8th and last session of 5th chapter, that is differentiation. In today's session, we will discuss sums based on minimization of cost function and maximization of revenue function and profit function. In practice, problems of minimizing the production cost of an item, maximizing the revenue by selling produced items, and maximizing profits are to be solved. We know that the production cost C or revenue R by selling produced items and profit P that can be represented as functions of x. So using the derivatives, we can decide when it will be maximum or minimum. So first let us discuss the conditions for minimizing the production cost function C. dc upon dx is equal to 0, and second condition, that is d square c upon dx square, that is second order derivative, that should be greater than 0. Same way, conditions for maximizing the revenue function are: first condition, that is dr upon dx is equal to 0, and same second order derivative, that is d square r upon dx square, that should be less than 0. Now third, that is conditions for maximizing the profit function P. Now that is dp upon dx is equal to 0 and d square p upon dx square, that should be less than 0. So for maximizing revenue or maximizing profit, second order derivative, that should be less than 0, while minimizing production cost C, for that second order derivative, that should be greater than 0. So let us start now sums based on these two. Question is, the daily cost of production for x tons of a commodity is 10x square minus 1000x plus 50,000. How many units should be produced for the minimum cost? And second question in this, also find this minimum cost. Now here, production cost function C, that is given 10x square minus 1000x plus 50,000. So our first condition, find dc upon dx, because that we are supposed to make equal to 0. So first we find dc upon dx. Now this will be 10 into 2, that will be 20x minus 1000x. So that will be only 1000, and this constant number, that comes 0. Now this dc upon dx is equal to 0. Based on this, we will find the value of x. So this is 20x minus 1000. This is dc upon dx, that equal to 0. Now x value we keep on one side and other value we take on the other side. So this will be minus 1000. If we take equal to that side, will be plus 1000. So value of x, that will be 1000 divided by 20, will be 50. So here value of x, that is 50. Now next step, that we will find first d square c upon dx square, that is second order derivative of dc upon dx. Now this will be 20x, so will be 20, again it's constant number, so that will be 0. So d square c upon dx square, that is 20. Now putting x value that is x is equal to 50 in d square c upon dx square. So that will be, because our second condition, that is it should be greater than, now here it is 20 only, which is greater than 0 only. So our production cost, that is minimum at x is equal to 50. Now our second question, that what will be this minimum cost, that also we are supposed to find. So for that, this minimum cost, we put this value of x, that is 50, in this cost function, minus 1000 into 50 plus 50,000. So this will be 10 into 2,500 minus 50,000 plus 50,000 will be 25,000. So this 25,000, that is your minimum cost. Hope you understand this type of sum. Next sum, the demand function of a watch is P is equal to 6,000 minus 2x. Find the demand which maximizes the revenue and also find the corresponding price. Now this is connected with revenue. Now here demand function P, that is given 6,000 minus 2x. Now we know very well that revenue function R, that is P into X. Now here P is 6,000 minus 2x into X. So this will be 6,000x minus 2x square. So our dr upon dx, that will be 6,000, x ka will be 1 minus 2 2s are 4x. Now our first condition, that is putting dr upon dx is equal to 0. So that will be 6,000 minus 4x is equal to 0. So value of x now we will find, that will be 6,000 minus 4x. If we take this side, will be plus 4x. So value of x will be 6,000 divided by 4 will be 1,500. Now our next condition, that is d square r upon dx square, that we will find. Now here you can see dr upon dx kai second order derivative of this. So derivative of dr upon dx, that will be 6,000, that will be 0 minus 4x, so minus 4. So d square r upon dx square, that is minus 4. So here putting x is equal to 1,500 in d square r upon dx square. So that will be d square r upon dx square, that is minus 4, which is less than 0 only. So revenue, that is maximum at x is equal to 1,500. Now we will find that corresponding price. So for that x is equal to 1,500. This value we put in demand function. that is P is equal to 6000 minus 2x. So that P, which price P, that will be 6000 minus 2 into 1500. So this will be 6000 minus 3000. So P will be 3000. So this is how we find this corresponding price. Last sum of today's session. If the production cost function for a producer is C is equal to 100 plus 0.015x square and revenue function is R is equal to 3x, then find the profit function. How many units should be produced by the producer for maximum profit? Now this question that is connected with maximum profit, that is profit function. Now for this profit function, it's very simple. How we find profit? Total revenue minus total cost. If we subtract, we get profit of that firm, company, etc. So here two different, one is given production cost function, that is C is equal to 100 plus 0.015x square, and revenue function, that is R is equal to 3x. These two functions, cost and revenue functions, are given. So how we find profit function? For that, this revenue function, that is 3x, we subtract cost function from this. So 100 plus 0.015x square. Open this bracket, will be 3x minus 100 minus 0.015x square. Next step, we find that is dp upon dx. So that will be 3, because x derivative of that will be 1 only, so let it this 3. This minus 100, that will be 0 only, and here minus 0.015 into 2, that will be 0.03x. So dp upon dx is 3 minus 0.03x. Putting dp upon dx, because our first condition that we make this equal to 0. So that will be 3 minus 0.03x is equal to 0. So based on that, we can find value of x. This, if we take equal to that side, will be positive. So here value of x, that is 3 divided by 0.03, will be 100. Now our second condition, that is d square p upon dx square, we find. So that will be, see, dp upon dx, 3 minus 0.03x, this 3 will be 0 only, minus this x 1 into 0.03. So this will be minus 0.03. Here intentionally I have written 0 because of this minus sign. Don't forget to write minus sign. If directly 3 का तुमने सोच लिया, it will be 0, and ये minus sign को ignore किया, so that will be completely wrong. That is why I have written here minus 1 into 0.03, which is minus 0.03. Now putting x is equal to 100, which here we find in this d square p upon dx square. So that will be d square p upon dx square, which is minus 0.03, which is less than 0 only. So at x is equal to 100, this value of this profit, which is maximum. So at x is equal to 100 only, our profit is maximum. So this is how sums based on cost function, revenue function and profit function is to be done. Today's homework textbook, page number 198, section E, question 5 to question number 12, section F, question number 4 to question number 6. All these sums are of this type. So do it, all these sums. This is an end of this session, and even your chapter and your syllabus of statistics, it's over. Thank you.